right, guys. Today I wanted to go over the proofs that we did in class. If you were here, if you were not here, proofs tend to be one of the more difficult parts of geometry. So let's look at what we did in class. So I uploaded this document to Canvas. If you go to my page, and let me show you my screen. Okay, so if you go to my Canvas page, you go to modules, and we are still in Unit 2B. So if you go to the bottom of Unit 2B, sorry, it's at the top. Today was the 6th, so 10/6/20 is today's date. And you can find all the stuff we did. So this is a blank copy of the notes. It's what I'm going to be showing you the presentation on. This is what we did in class. And next I have the notes. Everything that I'm about to talk about, everything we did in class is here. Okay. And then the homework was to complete numbers 7 through 12. Okay. And then this is where you upload your homework. So if you'll notice, this is weighted at 10 points. This is a little bit more difficult information, and it combines a lot of the stuff we've already done last week. So I weighted this a little bit heavier than the other stuff. So please, please, please make sure you submit this when you're done. Even if it's not 100% correct, I am not looking at accuracy. I am looking at completion for this assignment. Okay, so let's get into the notes. So we did 1 through 6 in class together. So let's do those right now. So I like to use a couple different colors of pen or highlighter when I'm looking at these. And the first thing I do, I look at all of my given information and I mark up the triangle according to whatever the given information tells me to do. Okay, so on this one, it says given segment AE is congruent to segment CB. AB is congruent to segment CB. And then also AB is congruent to CD. And then lastly, so check those off. We did AE and CB. We did AB and CD. Now it says B is the midpoint of ED. So B is your midpoint. That means that, so definition of a midpoint, if you recall, a definition of a midpoint cuts a segment or a line into two congruent parts. Okay, so this is going to cut that into two congruent parts here and a part here. So now as I'm filling this in, when you have a proof, the first statement is your given. That is always going to be your reason number one is given. Right? Now, the stuff I marked in pink. So EB is congruent to DB. How did I know how to do that? Okay, I knew to do that because of the definition of a midpoint. And then how are these triangles congruent? So think about the stuff we've been doing over the past few days. We've got side, 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 angle, 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 side, or hypotenuse leg. Of those 5, remember, no butts, no batteries. And so what do we have here? We have a side, side, and another side. So this is just side, side, side. That is how those two triangles are congruent. we have 3 sides are congruent to each other. Okay, and it's as easy as that. Number 2. So again, take it slow, what you're given. Don't flip out because it's a proof. And you can't see that. Hold up. Okay. So we are given AB is perpendicular to BE. So I'm going to get a little highlighter to show you. AB is perpendicular to BE. BE is this entire bottom segment. And DE is also perpendicular to BE. When you have perpendicular lines, that creates a right angle. So we're going to have a right angle there, as well as right here. Okay. So we have done that. And next it says AC is congruent to DC. AC and then DC is there. Okay. Did that. And then lastly, angle BAC, so this angle, is congruent to this angle EDC. Right? Prove that triangle ABC is congruent to triangle DEC. Okay, easy enough. So reason number 1 is you're given. Angle B and angle E are right angles. How did I know to put those right angles where I did? Because that's where those lines intersect. Those are perpendicular lines. Perpendicular lines create right angles. So reason number 2 would just be definition of perpendicular. Yes, this little upside down T means perpendicular. It's a definition of perpendicular lines. Okay. Angle B is congruent to angle E. Okay, they're right angles. And you know that right angles are congruent to each other because of the right angle congruence theorem. And then triangle ABC is congruent to triangle DEC. Well, let's see how. We have 2 angles and a side, 2 angles and a side. But the side is not in between the 2 angles. So it's not angle, side, angle. It's got to be angle, angle, side. Okay. Number 3. So again, look at your given information, fill that in. Segment GK is congruent to segment ML. GK congruent to segment ML. Angle GKM, that's going to be here, is congruent to angle LMK. LMK is this angle, okay? So we did those. And prove triangle GKM is congruent to triangle LMK. All right, so reason number 1 is always given. MK equals MK, or MK is congruent to MK. Anytime you're setting something equal to itself, that is just the reflexive property. Okay. triangle GKM is congruent to triangle LMK. Okay, what is the reason that proves that? Well, look at what you're given. Okay, something I didn't mark that we just went over was MK equals MK. Basically, these two triangles share this side. Right, so the angle is in between the two sides, yes, and it's up here too. So this is just side, angle, side. Okay. Number 4. Here we go. Given angle S is congruent to angle R, and XT, careful with this word, bisects SXR. Anytime you have a bisector, it cuts that angle into two congruent angles. Okay. And they have a shared side. Okay, so let's figure out what this is. So the reason number 1 is given, always given. And then angle SXT is congruent to angle RXT. Sorry. SXT is here, this angle. And then you have angle RXT. RXT is here. What allowed me to make those two angles congruent to each other? Well, when it told me to bisect, that's what an angle bisector does. It cuts this in half, and it creates two congruent angles. So this would just be definition of angle bisector. XT is congruent to XT. That's setting it equal to itself. That is reflexive property. Then lastly, how can we prove that these two triangles are congruent to each other? What information do we have? We have two angles and a side. Two angles and a side. Okay. In order for it to be angle side angle, so a little trick here. If you can draw a line between the two angles like that, and it's that side, that would be angle side angle. Okay, you cannot do that with the side we are given here. So this has to be angle angle side. Okay. Number 5. Given FT is congruent to FR and ST is congruent to SR. Okay, I just marked those. Prove that triangle FTS is congruent to triangle FRS. Okay, so something we didn't mark, they share a side. Okay. So reason number 1 is given. Okay, what allows us to use reflexive property? FS is congruent to FS, that shared side. And then finally, your last statement is always what you are trying to prove, so you just copy that information down. Triangle FTS is congruent to triangle FRS. And then how do we know that? Well, look at the information you're given. You're given a side, and another side. So this is just side, side, side. Last one. Okay, number 6. given that H is the midpoint of segment MK, so this is our midpoint. So it's the midpoint of MK and DQ. So we have congruent segments here as well as there. And this is one of those bow tie questions. So we have vertical angles. Okay. So statement number 1 is always what you are given. So just copy that in. H is the midpoint of MK and QD. And that's our given statement. Next statement, segment MH, that's here, is congruent to KH, that's here, and QH is congruent to DH. Right? So how did I know? So how do we know that those two segments are congruent to each other? We know that because H is the midpoint. So we just say definition of a midpoint here. Right? Angle MQH, MHQ, sorry, I misspoke. MHQ, that's here, is congruent to angle KHD, that would be here. So those are congruent because of the vertical angles theorem. And then your last statement is always what you were trying to prove. So you literally just copy this down. Triangle QMH is congruent to triangle DKH. How do we know that? Well, let's see what we're given. We're given two sides and an angle. So my little trick, I showed this to people in class today. So if you have a triangle and the angle is in between the whiskers, you can make a little face. So if the angle is in between the two sides, it's side angle side. That's what's going on here. So this is just side angle side. Okay. Your homework was to finish this, and I will show you what that is. So we did 1 through 6 together. So your homework tonight was to do 7, 8, 9, 10, 11, and 12. Okay, and that is all. Thank you for watching.